Cool. So for today, I have like three things to show. You know, what, why, and how, right? So that's the only three things we care in this webinar. So for the what part, we're gonna introduce Dragonfly, the open source project, as well as our cloud services. We're gonna introduce like for newcomers who are not familiar with this technology, we're gonna spend some time there. BullMQ, similar deal, like as you can probably tell from its name, it's MQ background job processing system, but what others it can do, like what other features BullMQ provides, why it's a very important part of the ecosystem, right? And then we're going to talk about like why are we doing this, right? So yeah, we have this two systems, so what, right? So maybe the reason why we put them together, right? Like what else, like what optimization, what, the engineering team, the open source community, like what's that all about, like, how we put things together. And then finally, we're going to see a demo in terms of how to, deal with heavy BullMQ workloads with Dragonfly. Right, so yeah, and that's the agenda, and let's try to, follow them and go through one by one. So first thing off, what is Dragonfly, right? So Dragonfly is an open source project. As you can see, we have our GitHub repo over here, github.com/dragonflydb/dragonfly, or just Google DragonflyDB. It's very easy to find us, right? So what is it, right? So Dragonfly is a drop-in replacement of Redis, but it's much more performant. So what does it mean by, drop-in replacement? Sometimes I get questions all the time. Folks are still, confused when first time see it. So drop-in meaning that it's super highly compatible, right? So Dragonfly currently support roughly 300 the most commonly used Redis commands. So which means that if you're using those common commands, like not super, uncommon ones in Redis, right? If that's the case, if you have an application running already on Redis, right? So theoretically, the only thing you need to change in your code is the connection string. Before you're pointing to your Redis instance, now change the connection string, and the credentials so that it points to a Dragonfly instance. Maybe it's for caching, then you can rewarm the cache. The data doesn't really matter. We can also migrate the data over, but essentially from a developer's perspective, that's the only thing you need to change. So pretty much after that, you would have like the very familiar and the very good developer experience that Redis has, right? So it's the same thing. You use the same commands, you use the same client libraries that you're familiar with, right? So that's basically how it is. Oh, I just realized that I didn't add my slides to the stage. Sorry about that, but I hope you can see now. Yeah, let's recap just a little bit. We're going to do what, why, and how. And we're at the what stage, and we're talking about Dragonfly at the moment. Cool. So same developer experience, but much more performant, and from a DevOps side of things, like it's also easier to manage, right? Because Redis by its nature, it's like mostly single-threaded technology, where the data manipulation portion of Redis is happens single-threaded, right? So it does the in-memory operations of the data, and that's why for a single Redis instance, it cannot utilize all the hardware resources underneath, right? So which means that if you have like a very powerful machine and you want your Redis topology to fully utilize that piece of hardware, that typically means that you need to do clustering for Redis even on a single server machine, right? So that increases the complexity. So but for Dragonfly, that's not the case. Just take the Dragonfly binary, that single binary, and you put it on a powerful machine, and Dragonfly is able to squeeze like every single bit of performance of resources that you have on the machine. And so based on our benchmark, Dragonfly is able to achieve 6 million. We tried big machine that's roughly 6.5 million QPS already, and it's able to handle up to 1 terabyte in memory data as well on a single instance. So yeah, that's the reason why Dragonfly is first built. We are part of the Redis or Volkey, nowadays ecosystem. So same API, same commands, but we're much more performant. And it saves cost as well because it utilizes your hardware better. So maybe you don't need as many servers as you need, right? Yeah. So we also have like a very active community. Like here today, I'm like hosting this webinar. If you have questions, feel free to join our Discord server as well. I will talk about where to find things at the end of the session. And obviously GitHub, because it's open source, GitHub issues is a good place where if you have questions, if you encounter problems or feature requests, stuff like that. Cool. Next up, we're going to talk about BullMQ, right? So BullMQ is also an open source project. It goes as github.com/taskforce/BullMQ, right? So, or just Google BullMQ. It's very easy to find as a very popular project as well. It's open source, and as the name suggests, it's a MQ. It's a background job processing framework. It's written in Node.js, so it can be used by Node.js clients and also Python clients, right? And BullMQ, it uses Redis or Dragonfly as its backend storage system. So it's a framework that's built up like on top of Redis or Dragonfly. So using Redis or Dragonfly, as the backend storage system. And we're not saying this just because Dragonfly is compatible with Redis, right? So we actually, I'm gonna tell the journey story like a little bit later, but we actually worked with the BullMQ team and others, maintainers together in order to make this integration happen, because that's the power of open source, right? So why is open source so important? I think the BullMQ Dragonfly integration story is a great story, and it's just one side of the open source community. So what happens is that we realized that BullMQ is a popular framework, and obviously we want to kind of really be part of the ecosystem. Maybe people can try run BullMQ on Dragonfly. That was the very beginning, right? So we tried it ourselves as well, and then we saw that Dragonfly is supposed to have higher performance, by its underneath like modern multi-threaded architecture, right? But when we first time tried it with BullMQ, that wasn't the case. So Dragonfly was actually, performing a little worse than Redis. So we started to investigate that, right? And we also get just help from the BullMQ author, Manuel, just asking why, like how internally underneath BullMQ works, right? It turns out that BullMQ heavily relies on Lua scripting, and in the script, many of the keys are unknown or like undeclared in the script, so that it's an okay thing for Redis, but for Dragonfly, that kind of increases the overhead, when we're in such situation, right? So later on, we figured ways to improve the performance. So basically, the two teams work together in order to make this happen. On the BullMQ side of things, Manuel, he has a BullMQ consulting service as well, right? So sometimes like his users also was facing like bottleneck of Redis, like it's maybe there are too many jobs to write and consume, and we don't know how to configure the Redis instance, like what's a good way. Then it became the bottleneck, right? So Dragonfly as the backend, it won't be the bottleneck because it's able to fully utilize your hardware underneath, right? So it's like a win-win situation where we give like a new option as a backend storage, right? And users like can choose. Like there are always trade-offs, and maybe some people are hesitating because Dragonfly is new, but it's officially supported right now, and we're quite stable and much more performant as well. So yeah, that's like a whole long journey where the two open source team work together to make this happen, right? So after the whole iterations of optimization, this is a benchmark that we did with running BullMQ on Dragonfly. As you can see, we were running 8 threads of Dragonfly because Dragonfly is multi-threaded and is configurable. We were running 8 threads, and Dragonfly actually performs like very well. I think that's more than 2 times, almost 3 times, than Redis instance, and it's not even on like a very huge instance if I remember correctly, right? So yeah, now it's not the bottleneck anymore. The backend storage it's pretty much like how busy your system is, how busy your services are. Like, are you able to saturate, all the resources that you have if you run BullMQ on Dragonfly? Cool. So yeah, with that said, let's dive into some of the code snippet here, right? So we talk about what we just talk about like what the 2 projects, Dragonfly, BullMQ, and why we did this integration, because the ecosystem is very important. It's very important for you. It's very important for us, right? And now we're looking at like how to do things, right? So in general, this is how easy you can create a queue or like a producer in BullMQ, right? You just call the constructor and give it a name, and then you can add message to this queue. And so that's the producer. On the consumer or worker side of things, we're going to see more code snippets later. But this is just how easy, if you have like a Dragonfly instance running, and we're going to see the connection details as well later, and then just use that connection, you're able to create a new queue or like a new producer, right? So, and just give it a name. But it's also a good practice to use some sort of prefix for your queue name, right? Maybe something like BullMQ, and you can group it and give it a group name, give it a queue name. Why is it good practice? Because it's not very recommended, but if your Dragonfly instance is also used for other things, like maybe for a cache, maybe for like locking, red lock, distributed locking system, then it's possible to have collisions on the keys, right? If the developers, like if I'm not careful, maybe I misremembered and I use like a same key name, right? That's why it's a good practice to have a prefix. By default, BullMQ also has a prefix like this, but that's configurable, right? So that's one good practice to keep in mind, to have a prefix. Another best practice here is this curly brace you see over here. So what that is, right? So that is actually something very important, if we're running BullMQ with heavy workloads on Dragonfly. That's something very important. So what it is, right? So it is a thing called hashtag. It's a concept from Redis cluster, but it's also it has similar like meaning in Dragonfly as well. So what this does is that imagine you have a Redis cluster, right? So it's your data, your keys are sharded into multiple instances, right? Then each of the key, they need to be kind of compute the hash, and we decide like which slot, and then in turn which instance this key should live on, right, in the cluster environment. But if you put a curly brace in here in the key, then the hashing algorithm, the hashing algorithm that decides which instance the key should live on will only look at the portion within the curly brace, not the whole key, right? So if you put like a hashtag in your key, that's the only thing we care about when we do sharding, basically, right? So back to Dragonfly. Dragonfly, we also have like a horizontal cluster mode. Recently we have a blog. It's a preview of that. We are actively testing the feature. But even if you're looking at like a single Dragonfly instance, because it's multi-threaded, right? So underneath, keys are also distributed onto those individual threads, not individual nodes in Dragonfly, like a huge Dragonfly instance, right? Multi-thread. So a key is managed by one and only that one thread in Dragonfly, right? So it's a similar story, right? So if you don't use hashtags, then we're gonna calculate the hash of the whole key and determine where the key lives, in a thread. But if you do use hashtags, we also only use whatever within the hashtag to determine which thread this key lives on. So that's how hashtag works. So with all that said, right, the optimized configuration you need for Dragonfly when running BullMQ are basically these two, right? So we want the single instance of Dragonfly to be running under the emulated cluster mode. And then if you also specify this log hashtag flag, then then that particular key is gonna be like managed by a single thread. And then because when you create a queue or create a producer in BullMQ, you can specify however you like the prefix, the whole name, but as long as it has a hashtag in there, right? We know that okay, this is a queue that needs to be run on a certain thread, and it won't move, and we don't have the problems of like undeclared keys anymore, right? So that will give you like the most optimized performance when running BullMQ on Dragonfly, right? So yeah, like all that explanation, basically this is what you need if you want to have optimized performance of BullMQ on Dragonfly. These are also documented very well in our documentations site, and you're welcome to check that out as well. But if you cannot do, we have like a fallback solution over here as well. But just remember that this is the optimized. Cool. So sometimes you do need different configurations for a server program. For a database, it's like Dragonfly doesn't require a lot. But sometimes when you have like special use cases, in this case BullMQ, again, because it heavily relies on JavaScript and everything, that's why we need this. But that's the only thing you need. Cool. Let's see a demo of all the things we just said, and using Dragonfly Cloud. So let's take a look. Let me see. So I'm currently on the Dragonfly Cloud service page. I have the URL directly, but if you don't know where to get here, go to dragonflydb.io, the homepage, and hit sign up. You'll be able to see this page over here. And it's so easy, like a few clicks away if you're first time here and you want to create a new account. But I already have an account already, and I'm just gonna log in right now. Yeah, you can use like Google OAuth as well if that's easier for you. I'm gonna use my email and then the password. Cool. Now I'm in here, right? So as you can see, it's a very neat and simple and intuitive UI. Dragonfly is the company behind the Dragonfly project. So this is a database infra place. So things doesn't have to be like super fancy, as long as it gives all the functionalities that you need, right? So we try to keep this simple and intuitive, right? So what I'm going to do right now is that I'm going to create a new data store. So basically, Dragonfly instance uh, on the cloud. What I'm going to do right now is I'm going to click add new, and here I'm just going to give it a name, maybe something like build pass. Go away one pass, and you can choose the cloud provider as well, and the regions. Just make sure that your application runs very like co-located with your Dragonfly instance, right? Because Dragonfly is super performant. As I said, it does like millions of QPS, and every single one of them they have like sub-millisecond latency. Right? But if you have like your service and your Dragonfly instance like running far apart, like no matter how performant Dragonfly is, like the speed of light, like the physical limitation that cannot be overcome by us, right? So make sure that you really have like a very close location between the services and your database instance and Dragonfly instance as well. Here, let's see, we have like very massive instance. Um, because of my account, I think I'm gonna go for 50 for today. That's like way more than enough for today's demo, right? And then we have like two options here: standard and enhanced. What does it mean, right? Enhanced, it gives you like more CPU for the same amount of memory. So still 50 gig, but the CPU is more powerful, maybe more cores, right? So it's it's like maybe you don't have like a very large in-memory workload in terms of data size, but you have like very heavy traffic, constant read and write and acceleration as well. That's the should be the type to go. So let's try enhanced for today. Security, this deserves like a whole lot of video webinar, right? So we can do VPC, we can do like a virtual private cloud, like the PGP connection, like between just your service and Dragonfly. So that's the most secure and probably the fastest because the network never leaves your cloud infrastructures, right? So it's internal, it's like a intranet, right? So that's recommended for production, but for today, that's not do that. Yeah, so that requires you to create a network first and then come back here to do the data store. POS for encryption, yeah, that's not do that for the demo purpose as well, but in prod, just make sure that your credentials are highly secured and VPC is like highly recommended. Cool. Then for durability and HA, right? So depending on your use case, if you're using Dragonfly as a cache, then we have the cache mode. So it's one flag, server flag that we have for Dragonfly. Unlike Redis that has like 8 or 9 eviction policy, Dragonfly has only one, which is a very smart algorithm that can expire your keys like in a more sophisticated way. Not it's like a combination of a few LRU. So yeah, it's like quite powerful. In our case, because we're using it as a BullMQ backend, right? So we can't evac any keys. So that's that. Then we also have availability zones. So you can choose like the primary and where you want your replica instance located, right? So you can choose, I remember, yeah, up to 2, right? So let's see, I just want one primary in this case, but yeah, this is a way you can have high availability, and they all reside in the same zone to ensure performance at the moment, right? And then finally, for today, most importantly, the thing you need to check is this checkbox for BullMQ. right? So basically, what it does, it sets the two server flags that I mentioned earlier for you, so that you don't need to worry about, how to set up properly. So then you do that. Yeah. By the way, Dragonfly is integrated with like other um, systems as well, like Sidekick, or Sidekick is a MQ system for Ruby, and Celery as well. Celery is an MQ system for Python. I remember that for Celery, because of how Celery works, like nothing special needs to be configured for Celery. For Sidekick, there is something special, but yeah, but I don't remember exactly. It's been a while, but the thing is that we will, if it's something that is super important, maybe in a newer version of Dragonfly Cloud, we will include that as well. We will try to include more specific specializations here, so that you don't need to worry about the server flags. Cool. That's with all that said, let's create this instance. So after I'm done with the click ops, it will take like a minute or two. In the meantime, why don't we look at the code of today for a little bit, right? So I have this very simple producer and worker code here for BullMQ, right? So, there are many use cases, you need background job processing, but one of them is probably for sending emails, right? Imagine that you have some sort of maybe an e-commerce site, and whenever the user places an order, you capture all that information, the order information, and you save that in database, right? So we kind of want to give the green thumb up in the UI to the user as quickly as possible, so that they know that it's purchased, right? But things afterwards, like sending a confirmation email, stuff like that, maybe like settle the payment and everything, that can happen later, and we can always notify the user if something goes wrong, right? So sending an email is like very valid use case of using BullMQ. And yeah, as you can see here, as I explained, we can create a producer or a new queue just this easy, right? Best practice, make sure that you give it a prefix, and because we're running on Dragonfly, make sure that they are properly grouped, in whatever way, uh, as long as you have like a hashtag in there, so that your queues are distributed evenly onto different Dragonfly threads, right? So that's one thing. Another thing is, as you can see, BullMQ is very, very feature rich, right? Like you can have just like a regular queue. You send item to it, and on the other side, you have a worker to process that, right? But you can also send a delayed message, so the message come up later, right? You can also prioritize, a message, and one means like the highest priority, and this huge number means the lowest. And all these things, they don't happen on the queue level. So it's not a configuration of the queue, but it's a configuration of individual messages, right? So that's how basically feature rich and powerful BullMQ is. And here you can also specify like, oh, please delete my jobs after a certain time. They're completed. I don't care that much. If you do, then don't remove them, and we can keep at most how many jobs as well. These are the things that consumes memory or storage in Dragonfly, right? So set a proper retention period as well. But yeah, overall, this is how easy to create a queue or send a message to that queue, right? And here is just like some command line. We're gonna pass in for delay and priority, right? So that's the producer side of things. On the worker side or the consumer side, as long as we make sure that we're reading from the same queue name, right? Prefix name, and we were able to like dequeue a job, an item from the queue, and we do whatever we want. Maybe we call the email vendor API over here, and then then the job is pretty much processed, right? And this process can like run indefinitely, like forever, and just like hang there waiting for new items to come, right? Cool. So that's the thing we're going to see today. So what I'm going to do is like I'm going to check the status. As you can see, this 50 gig. It's not huge, but it's also not small, right? Like 50 gig is a lot in memory. So over here, because for demo purpose we allow public, so here's the thing that I need. I'm going to grab the connection URL. And back in code, let me just replace this URL over here, so that for the rest of the demo it will be using the instance we just created, right? And back to the instance, we can also have the Grafana dashboard over here for monitoring as well, right? For the CPU shouldn't be this high. Maybe it's like during the creation phase, but this gives it some time, and maybe I can just arrange it a bit, as well, and see how things goes. Cool. So yeah, with the code in mind, let me switch to my terminal to run the commands, right? So we have this producer we just saw and this worker over here, right? So what I'm going to do right now is on the first, the top left terminal, I'm going to run the worker and just let it run there, right? And then I can start to produce jobs to that queue, and the worker should be able to process that job, right? So as you can see, I mimicked email item to the queue and email added, producer comment, because I exit the producer, after it's done. But you can reuse that queue object in your code as well. And here, that's the worker. You process the first email, and that job is removed from a queue, or means that it's completed. Like not necessarily deleted, but it's an item that shouldn't be seen anymore, right? So yeah, then you just grab my connection string over here again, and then you try to talk to that Dragonfly instance as well. As you can see, we should see a few keys that's being managed by BullMQ, right? Like you see the prefix, the hashtag, and this is the HTML. This is the item we just processed. As you can see, yeah, BullMQ keeps track of all this kind of information, like when this is processed and finished, right? Like whatever data it has, stuff like that. Super quite powerful. And the return value is stored as well, right? Because we're returning success, the string, in code as well. Cool. So one thing I can try is that I can try to specify, let's say, the delay and the priority of a job, right? Let's see if I do a delay of, let's say, 10. So that's 1 millisecond. So that's 1 second. Let's do 10 seconds, and then we give it, let's say, a priority of something like 200. And very quickly, I do that again, but with the highest priority, and let's say just 1 second, right? What you can see is that, this is the third email that we queued, but we're only asking for a delay for 1 second. And, it has the higher priority as well. That's why the third email is being processed first. And then roughly 10 seconds later, the second email that we queued over here, that's also being processed by our worker, right? So yeah, this is basically just to show like how feature rich BullMQ is, right? And then let's see, back to our code for a little bit. Yeah, it's basically we just saw this worker code in there, running indefinitely, waiting for new items. And we see this producer code where we were able to pass our delay and priority via the COI, right? So we just saw these two pieces kind of in action. Cool. What I'm going to do right now over here is that I'm going to stop the worker for a sec and clear, and also clear here for the producer. On the Dragonfly side, let me just flush this database. By the way, don't do key stars in production and don't do flush DB in production. Yeah, I'm only doing that for demo purposes, right? Like these are dangerous commands, right? Because this is like very costly and is essentially like saying that, oh, I don't want my the data and for demo is going to be fine, right? Cool. So now I didn't have anything in this Dragonfly instance. What I'm going to do right now is to take a look at a second program called concurrency. Basically, it's doing very similar things, trying to mimic email sending scenario, right? But this uses like the worker thread from Node to add some sort of concurrence, right? So it's kind of like the benchmark tool, right? But maybe it's not able to saturate I don't think it's able to saturate the Dragonfly instance that we have because it's very hard to saturate that, right? You have um, like a producer sending stuff, and on the other hand, you have like worker consuming. So overall, if the worker is running properly, like the message shouldn't pile up, right? So that's one thing. And also another thing is that in compared to things like super heavy caching, right? Like this use case is still, I personally consider it like, not as heavy as like moderate. Also, because of the BullMQ framework, the code, it uses Lua script, but overall, it's using like Dragonfly like very efficiently as well. So it's quite hard to saturate the whole thing, right? But basically, this piece of code does similar producer worker, but we kind of add more concurrency in there, just to see, just to try to push like more jobs to BullMQ onto Dragonfly and then consume that, right? So I'm gonna grab this command over here. I'm just gonna use one terminal for now, doing the concurrency. And yeah, we're doing like just for 10 seconds, 16 writers, 16 readers, and we're trying to mimic 46 queues, right, in BullMQ. And just run that and give it some time, roughly 10 seconds. So it's doing the same, and we just try to push a little bit, in terms of a more realistic scenario where you have like microservices, right? Potentially you have like multiple server instances producing at the same time, and maybe you have one or more worker, like in the email sending scenario, right? You don't have to have everything happen in order. So multiple workers are kind of okay as well. As you can see here, yeah, we hit around like 65K writes per second and roughly 30 for reads, right? So it's not a super high number, as I said, but there are factors in this, right? For instance, I'm running this locally, so it's my local computer, Toronto, talking to Virginia. I think that's the case. And also the program itself, yeah, maybe it's not able to saturate, to push, but as you can see, even just with that, we're able to get, a decent number there as well, right? And if we switch back to, let's see if we can see anything in the dashboard. As you can see, I think the CPU memory usage are quite like accurate right now. Yeah, because of the experiment we just ran, because a single Lua script in BullMQ also translates to like maybe a couple commands, right? So as you can see, we were easily hitting 20K commands per second, right? And there's no pressure on this instance at all. As I said, we barely used any memory because there's also worker consuming. If your worker is dead, then the message is going to pile up a little bit. But overall, you can see that this 50 gig instance like still quite healthy. We barely used any of it, right? Yeah, and I can try to change this number a little bit. Yeah, but maybe I'm not running this program like again collocated with the services from my local machine. So from my experience so far, it's still very hard for me to saturate the instance, right? So that's kind of proves that this instance is not under pressure. Oh, we hit 60K commands per second, maybe even higher than that, right? Because we're sending a lot of jobs concurrently, and as I said, each Lua script in BullMQ translates to a couple of commands. That's why this number is not trivial anymore, but it's nothing. It's really like not a big deal for this Dragonfly instance. And the connections of Dragonfly connections, don't spam it, but roughly speaking, the connections are quite lightweight as well. So yeah, like having some like high concurrency here. Use connect client pools, right? That's kind of like what all the library kind of does underneath. That's good practice. So yeah, as you can see, we went up to 70K commands per second just by running that script for what 10 seconds, right? And yeah, this instance is not under pressure at all. Yeah, let's see. I will, like after this, I will spend some more time with the script, see if I can even push this. But you get the idea. Like this is not quite a lot for Dragonfly. Cool. So with that said, back to my slide. Yeah, that's all I have for today. So just to recap, we covered the two projects. What is Dragonfly? What is BullMQ? We covered a little bit of the story where the two teams work together to make this integration happen. There are some server flags that you need to to run BullMQ with Dragonfly with the optimized performance. Or if you use Dragonfly Cloud, just make sure that you have this checkbox for the BullMQ specialization check, and that's it, right? So that's why, that's the journey. And in terms of how, we showed some code snippets where, shows how feature rich BullMQ is. And, we try to push a little bit of concurrency to the data store, and, it's still like quite healthy and, doesn't have any trouble in terms of CPU usage and memory usage and number of commands. Yeah, so it's dropping now. But imagine this number is constant, right? Then it's already handled a lot for your MQ system. Cool. And yeah, we do have our homepage, dragonflydb.io, and /community is a great place to be. And if you're not familiar with this, take a look very quick. So if you go to dragonflydb.io, and this is our homepage, under community, there are a lot of things that I'm working on that, the engineering team, the docs, and, our marketing folks working on. You can check our latest blogs, documentations over here. But one place, if you go to community and then hit this community button again, then you would see this page where the only thing you need to input is the email, right? By kind of joining or subscribe to this whole community magic, you would be able to get exclusive resources, like, the webinar opportunities like this. Sometimes our CTO Roman, he will be giving like, even more in-depth webinars. And yeah, you're here to probably learn from like what we can do, what you want to do with Dragonfly, but also to share and to shape the future of this project as well. So yeah, do make sure that you come to this page, homepage, community, and join. Yeah, with that said, that's all I have for today. And let's see if I have, sorry, I ran a little bit longer, but let's see if we have questions for today. Okay, I got one about cluster. Yeah, so the question is about the Dragonfly cluster. Yes, as I mentioned, we have two cluster mode. One is like Dragonfly, a single Dragonfly instance can emulate a Redis cluster, right? Why we do that? Because sometimes we have users migrating from a Redis cluster to a single instance because the single instance can handle more. So that migration, is a use case, and we want to make sure that when the switchover happens, the same cluster client library can be used, right? We want to make sure that everything kind of behaves the same, even though it's from a Redis cluster to a single Dragonfly instance. That's why we have the emulated mode. Recently, we also have a preview for the Dragonfly cluster we're developing and testing right now, by our engineer Boris. So yeah, this is like the multi-node cluster, like Redis cluster, right? So the difference is that on a single instance, you always have one Dragonfly binary, right? But if you have like 5 of them, you can have like 5 powerful instances, and every single one of them is running one Dragonfly process, right? Then the data is sharded. We can do a whole bunch of crazy things. You have like a much higher upper limit. Basically, the upper limit is removed because horizontal scaling is can be achieved by this. So yeah, more details in here. Boris also even shared some of the implementation details as well in terms of like say how a slot migration when that happens, what Dragonfly, each instance, like what do they do, stuff like that, right? So this is a early preview. It's not released in any of the official release of Dragonfly yet, but everything described in here is available on the main branch of Dragonfly already, right? So for BullMQ, yeah, really depending on like how heavy your workload is. As you just saw, I tried to push it a little bit with 64 queues with concurrent readers, writers, and you see nothing on this single instance, right? So yeah, but if you do have like super heavy, workload, yeah, we'll see like what cluster can do, right? Cool. Thank you for the question. Let's see if there's more. Cool. So I don't think there's more coming through right now, but don't be shy. If you have questions, again, remember to join the community. We have our Discord server. We have our Discourse, which is the forum. People go ask questions. People want to keep their questions kind of be there forever instead of like in a chat channel. That's where you should go. We have like questions coming in there as well. Events like this or in person, yeah, that's under the events tab. So tomorrow I'm going to be giving like another online talk with document database as well. And then finally the community page is what I showed earlier. And GitHub, obviously, all the developers know how to deal with GitHub issues. Go there as well. Cool. So with all that said, that's what I have. And I hope this is interesting for you, and I'll catch up with you later. Take care.